Hi everyone, welcome to our next lecture in our settlement track. Today we're going to be hearing from Beeta Susciicka, did I say that right? From the Warklaw University of Science and Technology, and she's going to be speaking about the evaluation of Mars colonization opportunities depending on its conditions. Thank you for joining us.
Hello, everyone. Let me briefly introduce myself. My name is Beata Susciicka, and I'm a member of InSpace group dealing with space engineering. I'm responsible for architecture and design. I'm delighted to be here today to talk to you about influence of Mars condition of its colonization possibility. The presentation is based on the IDEA City project proposed by my team, which qualified for the final of the Mars Colony Prize competition last year. Maybe you remember and know this project. Let me start with some general information about space. Human fascination with the space has lasted for centuries. For a long time, we have been striving for man to take his first step on another planet. This is how the crewed space mission were born. Many aspects of science and technology are being developed through space mission. In this way, we are pursuing the great goal of knowing the being able to populate the space, but we can also transform it into early realities and use it in our everyday life. Until now, man has only landed on the one celestial body, the moon. However, it appeared to be a dry and empty land with no atmosphere and low gravity that makes it difficult to move around. Other planets and moons have completely difficult environment for man, and there will be no possibility to adopt it. One of the ways is terraforming, however, is a long-term and dangerous process. And another way is to build artificial ecosystem. The settlements of the space and asteroid interiors is also considered. The colonization of Mars seems to be the closest to us for today's possibilities. The most important argument for this are relatively close to Earth gravity and the presence of various important local resources, including the most important one, water. Also, Mars is only the third most important celestial body nearest to Earth. Although the colonization of Mars may seem to us to be a distant subject, the first manned space missions are planned for several years. So far, many different space exploration programs have been created, including the establishment of the first human habitats. Crew mission to Mars will be a special kind of space mission to its duration. It's planned to be a few years mission, so the human aspect becomes as important as the technical aspect. For physical and mental comfort, it is necessary to design a human-friendly habit. It will be a significant challenge because the extremely conditions of Mars require a specific kind of design. There are many alternatives ahead, but on the basis of today's knowledge of the red planet and the development of technology, we can consider different models. There are currently only two missions on the surface of Mars. The first one is the Mars Science Laboratory mission, Curiosity rover, and the other one is ongoing mission on the surface of Mars. It's a mission to explore the geology of Mars. It's called InSight. Both of the mission are really difficult and full of problems. So now let's move to how to get to Mars. Currently, the heaviest payload placed on the surface of Mars with the Curiosity rover to provide the necessary elements for a Martian mission, such as food and water for astronauts, space modules, or vehicles for traveling on Mars. The first stage is to leave Earth and reach Mars orbit. For this purpose, a super heavy rocket is needed, which can deliver heavy loads to Mars. Currently, several organizations and companies are working on such rockets. The first of this is SpaceX. It is a private company that was the first to introduce reusable rockets. Currently, the most used rocket is Falcon. Falcon is able to put only 4 tons of space in Mars orbit. However, this company has a rocket that can deliver 4 times heavier payload. It is Falcon Heavy. The company also developed their largest rocket, Starship. While previous rockets are able to deliver cargo to Mars, Starship is created to colonize Mars. In addition to private companies, government space agencies are currently working on this type of rocket. NASA is currently working on the Space Launch System rocket. It is a rocket that will make Americans return to space further than on the International Space Station. In this graph perfectly show that the difference between rockets. The next step is Mars landing. After reaching Mars orbit, the next step is to land on its surface. Due to the thin and rare atmosphere, it's a more difficult task than on Earth. Until now, as previously mentioned, the Curiosity rover was the heaviest load that was successfully planned on Martian soil. His landing was based on 4 stages. At the maximum, until now, the maximum load is limited to only 4.5 meters in diameter and 0.9 tons of weight. We have to fix how we have two different concepts how to fix this. They are based on the use of the thin and rare atmosphere of Mars to lose as much as possible the interplanetary volcano with which the ship approached landing, while not exceeding the maximum allowable temperature for the heat shield. Further development and testing of this technology are necessary for people to set foot on Mars. The Mars condition. The distance between Mars and Sun is 1.5 times longer than the distance between Earth and Mars. The period of Mars rotation around the Sun is 1.88 times longer and lasts 687 days. The length of the Martian day is about 40 minutes longer than that on the Earth. The diameter of the red planet is 1.88 times smaller compared to Earth. The water on the red planet necessary for the life support and existence of Mars does not occur in liquid form, but the land relief indicate that in the past there has been present. Currently, the water on Mars is present solid form in ice caps on the pole. Present knowledge about the raw material on Mars is not extensive, but the composition of rocks and soil covering the planet is known. It consists mostly of silicon and iron, which is the further can be used as material for building the first bases. If there are depositing of raw materials on Mars, it would allow the industry development in the Martian colony. In comparison to Earth, Mars is not a very good place for the development of life, even though it is located in the ecosphere. Life on Mars without special protection is not possible at the moment due to its condition, low pressure, no atmosphere to keep the gases needed for life. Another problem is the lack of nature protective barrier against space and solar radiation, which would allow to colonize movement freely on the surface of Mars without protective suites and would cause the creation of potential bases would not require thick walls. Okay, so let's move to Martian architecture. The first stage of architectural design is to carry out a series of analyzing regarding the environment in which we design. We have to take into account the condition, the location, and form of the base itself will depend on this. When choosing a place, we should be quiet among other maps of radiation and find location with low risk of space radiation. Here is graph which present how area is connected with architecture. Surface area of Mars is about 28% of Earth. The terrain forms of Mars are similar to those we know from Earth. They are very diverse. The only difference is that there are no land intersection in the form of water body or river crossing. The present landscape of Mars has shaped over a million of years. The main factor influencing this process were winds, water, volcanic eruption, and meteoric falls. Currently, only winds affect the surface of Mars. They carry the dust that from shipping sandstones. The Martian terrain form can be classified into several main groups: plains, hills, craters, fjords, whale, volcanic. The individual groups and their impact or architecture is shown in the table. Architecture relates to topography is different ways. We can distinguish in the following groups. The first one, depending on topography, referring to specific forms. The second one, inscribable in the landscape but requiring terrain transformation. And the last one, completely independent of the topography. Our project is located in a plain area, the proposed location in Arcadia Planitia, but we consider also use another location. And the form of the base may depend on the terrain, and on flat terrain it can take any shapes. It can be made on surface on a hollowed out below the ground surface. The external form is dissipated by the pressure difference between the dense atmosphere inside the habitat and the rare one outside. The gar inside will exert considerable pressure on the walls of the building. Therefore, optimal pressure distribution can be ensured by rounded forms, basing streamlined forms: sphere, cylinder, torus, dome, arc, vault, and cut-off torus. This is why we use this form in our project of Idea City Colony. And we choose protection against radiation, which was 3D printing with regolith. We use it because protection was for us extremely important. And this is how our base looks like. Mostly is underground because then it's more safety. To be able to live on Mars, apart from providing basic conditions, people need water for drinking, hugging, and food breathing. Water is also used in the manufacturing and technological process. When setting up the first colony, it's necessary to consider a suitable location to have easy access to water. In order to building a self-sufficient colony on Mars, it is necessary to have basic raw materials without the need for transportation from Earth. thus enabling the development of industry production of basic technology equipment, construction, and expansion of the base. Providing materials necessary for the development of the colony from Earth would be too expensive and would require a very long time. Energy, different ways of generating energy are being considered on Mars. The first mission will need several dozen kilowatts of power. On Mars, we can generate energy in a similar ways as on Earth. Nuclear, solar, and wind energy are being considered, and it will even be possible to use geothermal energy. To provide food for a people in the Martian colony, it's necessary to cultivate on the local place on account of the high cost of transportation food from the Earth, as well as the time of waiting for it. However, the main part of the Martian diet will be food in the form of plants, like vegetables or fruits, but plants will also be used for medical purpose, clothing, oxygen production, as well as for decorative purpose. Below are presentation methods of graph plants that could be used on the red planet. The initial stages of development of the first colony should include many plants in the diet due to the simple and economic cultivation. At a later stage of colony development, fish can be introduced into the diet. Unfortunately, the tanks in which they are bred take up a lot of space. In the later stages of colony development, artificial meat can be used due to the fact that breeding food animals is uneconomical compared to the energy that can provide. Humans function in different conditions that Earth's during long-term exposure does not bring beneficial result. It is all about mental and physical health and well-being. An example is the International Space Station, where gravity does not exist. Man is exposed to space radiation as well as lack the adequate gravity. The rest of the conditions are provided and similar to earthly ones. However, what will happen to a human being when they move to completely different planet? While the time will not be too long, the change in the human body may be insignificant, but spending the rest of life in completely different conditions than on Earth certainly has an impact of the quality of this life and may even shorten. Nevertheless, the further generation living in Mars colony will be perhaps even more adapted to the continuous there. The planet Mars is a natural direction of the space expansion. We want to not only discover it, but also colonize. Although conditions on Mars are close to the Earth from all the planets, colonizing it will not be simply task. So we have a lot of work to make this real. Thank you for attention.
Awesome, Beeta, thank you so much for joining us. We're going to go ahead and start with the Q&A portion of the meeting. So we have one question. What do you foresee being the primary economic output of Mars cities?
Yeah, we did. We tried to do like we make like few phase to try colonize Mars. We showed it in different presentation.
And what do you think we can do now to prepare people for life on Mars? And with that, how can we inspire the common person to prioritize space colonization?
Like we can thinking about this, like we can training people and finding new opportunity, like to build a Mars base or to live together in small place.
Do you think that existing corporations, such as Siemens, will have a significant impact on how early colonies are developed?
I think yes. We have to. It's. I think we can do this in not like really close future, but a little far. But everything what we do now is really important.
Beata, that was a fabulous presentation. Does anyone else? Oh, look, I have one more here. Hang on. The question is, hang on, chat window keeps jumping. Are there thorium deposits on Mars that could be used in nuclear reactors?
In our project, we assume that yes, we are trying to do this. Like, we are not sure that is the best thing, but we are thinking that it's one of opportunity that's for using this.
Okay, and Gary is asking, soil on Earth is important to cycle nutrients for crop production. Do you see that as a focus with Martian soil that would provide a long-term solution for continuous food production on Mars?
I can answer this question if you want, Beata. So we think that soil isn't efficient way to grow plants because hydroponics or aeroponics are more efficient. So it's not good to focus on soil because we even now on Earth have more efficient ways to have plants and crops.
Okay, and the last question that's here in the chat window is, have you networked with Asgardia? How can we inspire the common person to prioritize space colonization?
Beata, do you want to answer? No, we have never networked with Asgardia, but we heard about it. And we think that everyone should inspire the common person. So the best way is just to show why it is so important and how we can do and how the common person can be involved in space colonization. So that's the most important thing because most of the people don't know how to get involved. So that's the biggest problem in our minds.
Well, we're almost out of time, and I just wanted to take a moment to thank you both very, very much. The presentation was very good, very inspiring, and we hope to talk to you again soon.
Thank you.
Thank you.